Welcome to Pristine Maths Club. Like, comment, and subscribe. Okay, if A is equals to A, B, C, D, that's matrix A. Then the inverse of A is equals to 1 over determinant of A, which is equals to AD minus BC multiplied by the adjoint of A. Adjoint of A is that the leading diagonal will be interchanged, so that is A and D will be changed to D and A, and the other diagonals will be multiplied by a negative number, so we have minus B and minus C there. Okay, so the B and C will multiply by a negative number. Let us look at this example. We are given A to be equals to this. We have to find the inverse of A. To get the inverse of A, okay, we can first say that 1 over determinant of A, which is 2 times 5, which is 10, minus 3 times 4, that is BC there, okay, give us minus 12. Then we get the adjoint of A there. So we interchange the leading diagonal. Okay, so it becomes 5, 2. Okay, then we multiply minus 3 and 4 by minus 1. So become minus 1 times minus 3 give us 3, minus 1 times 4 give us minus 4. Okay, we will simplify this and get the final answer. So the V inverse of A is equals to 1 over the 10 plus 12 there is equals to the 22. Okay, we write our matrix there again. So the 1 over 22 multiply everything inside because it's a scalar multiplication. So the inverse of A is equals to, we have 5 over 22. We have 3 as well over 22. We have minus 4 over 22. And we have 2 over 22. Okay. So we can cut the one that can be cut there to year 1 to year 11. So the final answer for the inverse of this is given as this. So that's our final answer for inverse. Now we want to look at the identity matrix for 2 by 2 and 3 by 3 matrices. Okay, that is 3 by 3 matrices, 3 rows, 3 columns. The identity matrix means that the leading diagonal, the entries of the leading diagonal must be equals to unity, which is 1, while the other diagonals, okay, the same thing also for 3 by 3, the leading diagonal will be 1, and the rest of the other diagonals, the rest of the entries will be 0 as well. It will be 0. So this is what is called identity matrix. Okay, when a matrix multiplies by its inverse, it gives identity. Okay, when a matrix multiplies by its inverse, it gives identity. Let us look at an example. If we have 3, for example, the identity of product is 1. 3 multiplied by its inverse or reciprocal give us 1 because the identity of multiplication is 1. So this one gives us 3 raised to power minus 1 give us 1. So we should know that the identity of multiplication is 1. So when the 3 multiplied by its inverse is equals to 1. Now we want to apply this to solve this. We are given the inverse of A. We want to get A. Okay. To do this, we say let A equals to the entry A, B, C, D. Okay, so we now want to get A, B, C, D to know our A. Remember the identity matrix, we have already done that. That is the identity matrix. So we write the formula down. The A multiplied by its inverse will give us the identity. Okay, so we have our A there. We'll write the A. Okay. These are A multiplied by its inverse. The inverse is this as well. Minus 2, 3, 3 minus 4. The equals to the identity. Identity is also there. Okay. 1, 0, 0, 1. Now to solve this, you multiply the A by its inverse. You know that the row usually multiply the column. In the multiplication of matrices, so A will multiply minus 2, that is the first row, first column will multiply the first row, first column in the so A will multiply minus 2, give you minus 2A. The B will multiply 3 for the first row and first column. Okay. We also take the first row multiplied by the second column. A will multiply 3, 3A, and the B will multiply minus 4. In the first row multiply the second column. Okay, the second row now we multiply the first column. C will multiply minus 2, minus 2C, and D will multiply 3 plus 3D. Okay, first row again we multiply the second column. C multiplies 3, 3C, and D multiply minus 4, minus 4D. Okay, so that's the multiplication of the two matrices. They are equals to the identity. Okay, but for you to be able to do this, please make sure that for the equality of a matrix, so the entry equals, so 3A minus 4B is equals to 0. You first do the one that are equal, that equate to 0, please. So it's easier for us in that way. So we get our A to be equals to 4B over 3. Okay, so we also take the second row first column there, minus 2C plus 3D. We equals to the second row first column in the other side, which is equals to 0 from our identity there. Okay, so the 3D now is equals to 2C. Okay, so D is equals to 2C over 3. Okay, so from there we can now take the rest. The first row, first column, minus 2A plus 3B, minus 2A plus 3B, which will be equals to first column in the identity matrix also as well. Okay, which is 1. So since we know our A is equals to 4B over 3, we substitute. So we have minus 2 into bracket, the 4B over 3, sum plus 3B is equals to 1. So you have minus 8B over 3 plus 3B is equals to 1. We can multiply through now by 3 in order to cancel the denominator, which is 3 there. Okay, we multiply everything now. So 3 multiply minus 8B over 3 plus 3 multiply the 3B is equals to 3 multiply the 1 there. So you have minus 8B plus 9B is equals to 3. Minus 8b plus 9b will give us b is equals to 3. We have been able to get b now, one of our entries. So the same way, second row, second column, they equals to 1. Okay. If you look at it, 3c minus 4d is equals to 1. Okay. So d is equals to 2c over 3. We put it, substitute for that. So we have the 3c minus 4 into bracket 2c over 3 is equals to 1. So minus 4 times 2c, 8c over 3 is equals to 1. We can now multiply through by 3 in order to cancel the denominator. So we have 9c minus 8c is equals to 3. Okay, so this is c is equals to 3 as well. Okay, now to get d now, d is equals to 2c, where our c is 3 now. We put it there. So 2 times 3 divided by the 3. So our d is equals to 2. Okay. Then it remains only a. A is equals to 4 times b. And we are aware that our b is equals to 3. So we put it there. Okay. Divided by 3. So the a is equals to 4. So we put all the entries in the matrix A that we are looking for. So we'll get values. Okay, all the entries we put it there. A is equals to 4. Okay, 3, B, C, 3, and D is 2. That is solving simultaneous equation using Crammer's rule. That is what we want to look at now. Okay, given matrix A, B, C, D, these are the with entries of matrix A. Determinant of A is equals to the leading diagonal, which is it can also be written like that. That's determinant of A. Okay. The leading diagonal is A and D, so we multiply the two together, so give us the AD minus, we also multiply B and C together, minus BC, and that is the determinant. How to get determinant of 2 by 2 matrix. Okay, now let us look at this equation, solve the simultaneous equation using Crammer's rule. In this case, we are going to write a formula down. Okay, these are the equation we'll look at. Okay, to do this, we have the formula for the x is equals to, we say the determinant of x over the main determinant, and to also get y, we say the determinant of y is equal to determinant of y over the main determinant, which is d. So we will have to write the two equations in augmented form. Okay, and how do we write it in augmented form? We have to the coefficient of x and y for the first equation is 3 and minus 1, and coefficient of that is 3 and minus 1 for the first equation. coefficient of x and y. Okay, and for the coefficient of x and y, second equation is 2 and 1. Okay, so you have a line there, and the constant is 12 and 13 for the first and the second equation. So we'll put 12 and 13 there. Okay, so in this case, that is, we have written the entire equations in augmented form. So to get our d now, is the determinant of the coefficient of x and y in both equation, which is a 3, minus 1, 2, and 1. So that's to get our d. So we'll get the determinant of this now. 3 times 1, you have 3, and minus 1 times 2. Okay, give us minus 2. So our d now is equals to 3 plus 2. And we have 5 for the d. Okay, so the next one is to get the determinant for the x. How do we get that? We just go for the coefficient of x there. So let's get the determinant for the x. That is the x now. Go for the x there. Coefficient of x is 3 and 2. We replace it with 12 and 13. Okay, so we replace the 3 and 2. So instead of writing 3 and 2 there, we write 12 and 13, which is the constant there. We write 12, 13, and we have minus 1 and 1. Okay, so now you find the determinant of this now. Okay, the determinant of this 12 times 1, you have 12 minus 1 times 13. So you have minus 13. You have minus 13. So you now have 12 plus 13. So you have 15. Sorry, you have 25 rather. Sorry, 12 plus 13 is 25. So we have to also get the determinants for the y. Call it dy. Okay, so we take the coefficient of y there, which is minus 1 and 1. We replace it by 12 and 30, which is the constant. So we are going to replace it by 12 and 13. Okay, so we now have the matrix 3, 2, 12, 13 for the dy now. So we have matrix 3, 2, 12, 13. Okay, and to get this matrix, just say 3 times 13, which is 39. We have minus 12 times 2, which is 24. 39 minus 24 will give us 15. Now, recall our formula. The formula is this. So to now get the x now, we have already gotten the x to be equals to 25 divided by d is our 5. Okay, so the answer here is 25 divided by 5 will give us 5. And we get the y. We have our dy to be equals to 15, and our D is 5 already, so we cut them. So we also have y equals to 3. So the solution of the simultaneous equation is 5, 3. Okay. So don't forget to subscribe, like, and comment on the page. Thanks.